You know, before anyone even thinks about building a skyscraper, they need a detailed blueprint, right? Without it, you just get chaos, super costly mistakes, and a building that might not even stand up. Well, in the world of software, that exact same essential blueprint, it's called system analysis. All right, let's get into it. Oh, we've all been there. You click a button and nothing happens. You wait what feels like an eternity for a page to load. You're left just wondering, what were the developers thinking? It's so frustrating, right? But what's the real reason so much software feels like this?
The real secret is that good software is never an accident. It's always the result of a really deliberate, critical planning phase that happens way before a single line of code ever gets written. And that phase is system analysis. When teams skip it, you get that exact kind of digital mess that we all hate using. So, before anyone starts building anything, you have to define the mission. What problem are we actually trying to solve here? And who are we solving it for? This, right here, is the very heart of the whole process.
So here's the official breakdown. System analysis is basically the investigative phase. Think of it like being a detective. You're looking at what's currently there, figuring out why it's not working, and then piece by piece, you define exactly what a successful solution needs to look like. It's all about understanding before you act.
And the goals at this stage are super clear. First, you dig into the current problems. Then you actually talk to the people who are going to use the system to find out what they really need, and you set firm boundaries for the project. If you get this part right, you've built a rock-solid foundation for the entire design and development team to build on. Now, this whole thing isn't just random guesswork. To build that foundation, analysts follow a pretty methodical investigation. It's a process that turns a kind of vague idea into a concrete plan, and it happens in 6 key steps. So the process kicks off with identifying the real problem. Then, and this is crucial, analysts check if a solution is even feasible before they gather up all the user needs. After analyzing all that data, everything gets written down in this critical document called the SRS, which then goes for a final review. See how each step builds on the last one? And make sure everyone's on the same page before any coding begins.
You know, what's really fascinating here is step 2, the feasibility study. I mean, before sinking a ton of time and money into a project, the analyst has to ask the tough questions. Do we even have the tech for this? Does it make sense financially? And maybe most importantly, will people actually use it? Answering no right here can literally save a company from a total disaster. Okay, so once we know a project is actually feasible, the real detective work can begin. This is the stage where the analyst gathers all the clues, the requirements that are going to define what this system needs to become. The first, and maybe most obvious question, is all about action. What are these specific things this system has to be able to do? You know, can a user log in? Can they upload a photo? Can they generate a sales report? These actions are called functional requirements. It helps to think of them as the verbs of the system, the concrete things it has to do, like calculate, save, or notify. This is the non-negotiable checklist of what the final product has to accomplish. But let's be real. Knowing what a system does is only half the battle. The other equally important question is all about quality. How well does it need to do all those things? And that brings us to non-functional requirements. So if functional requirements are the verbs, these are the adjectives. They describe the system's qualities, like how fast it needs to be, how secure the data has to be, or how easy it is for someone to use. A system that technically works but is painfully slow and confusing, well, that's still a failure, isn't it? So to gather all this info, analysts have a pretty diverse toolkit. They'll do interviews with users, they'll actually go and observe people in their real work environments, and they'll create these complex diagrams to map out how information is going to flow. It's a real mix of people skills and some pretty serious technical modeling. So, after all the investigation, all the clue gathering, the entire process leads to one single critical outcome. The final verdict, you could say. Every single interview, every diagram, every little requirement is compiled, refined, and organized into the single most important document in the entire project. And it's called the System Requirement Specification, or the SRS. This is the master blueprint. We've been talking about this whole time. It becomes the one source of truth that will guide every single person on the project, from the client all the way down to the last developer. And that is why the SRS is absolutely non-negotiable. It's like a contract, which helps prevent those big arguments and expensive changes later on. It's the official roadmap for the whole project. And without it, let's be honest, teams are pretty much guaranteed to get lost. Which, of course, brings us right back to our original question. What actually happens when you try to build something without this blueprint? Well, you get exactly what you'd expect. You get total chaos. I mean, when you look at why big projects fail, the biggest reasons, constantly changing requirements, bad communication, ignoring what users actually want, those aren't coding problems. They are all symptoms of a failed analysis phase. They are the direct result of skipping the blueprint. And the consequence of that is just staggering. Fixing a mistake in the requirements, like a simple misunderstanding, during this analysis phase might take an hour of someone's time. But fixing that exact same mistake after the product has already been built and launched, it can be 100 times more expensive. That right there is the incredible value of system analysis.
So the next time you use an app that just works, one that's fast, it's intuitive, it does exactly what you need it to do, just take a second. Because what you're seeing isn't just good design or clever code, you're actually seeing the result of an invisible, perfectly executed blueprint.